Hello and welcome to my channel. In this video, we will understand insertion sort algorithm. Insertion sort is a stable and in-place sorting algorithm. This algorithm places an unsorted element at its suitable place in every iteration by shifting each element in the array one at a time. If the current element is greater, it stays at its place. Otherwise, the element is shifted to its appropriate place in the sorted array. So here are a few steps that will help you to code insertion sort algorithm. We start with the first element and consider this as to be sorted. And now we are going to start the comparison with the second element, which is 12. We store it in a variable var. And now we are going to compare the value of var with this first element, which is already sorted. So we are going to have this condition 7 greater than 12, or you can write 12 less than 7. Now, if the first element, which is 7, is greater than the value stored in variable var, then var is placed in front of the first element. But as we can see, this condition is false, so there will be no change in the array and the outcome will be this. In the next iteration, we consider these two elements as sorted and we start with the third element, which is 5. So here I take my variable var and store 5 in it. And now I'm going to compare var with the value 12. So you can see we are moving towards the left side. So here I check if 12 is greater than 5. As this condition is true, so 5 will have to move towards the left because 5 is smaller than 12. So the outcome will be this, as 12 is making space for the element 5, which is smaller than this. So 5 will move towards the left hand side, which is this at index 1. In the next iteration, 5 will be compared with the element on its left, which is 7. So now this value var, which is 5, is compared with 7. So we are going to check this, as 7 greater than 5 is also true. So 5 will have to move towards the left hand side, and that's why 7 is making space for it. And in the outcome, 5 will be moving towards the left hand side of 7, which is smaller number, and this becomes my array after this complete iteration. Now we are going to consider this part of the array as sorted, and we start the iteration with number 1. So we store this value in variable var, and now we are going to compare 1 with the element on its left one by one with this 7 and then 5. So in the first place, we compare 12 with 1, as this condition is true. So 12 will move towards right in order to make place for 1. And then we will be comparing 1 and 7, as 7 greater than 1 condition is also true. So 7 makes space for 1 and 1 is shifted towards the left hand side. In the next iteration, 1 is compared with 5. This is also true. So 5 makes place for 1 and 1 is finally brought at its correct position in the array. So the outcome will be this. In the next place, you can see that this part of the array is sorted and we have this element getting into variable var, which is this. So now we are going to compare 6 with the element on its left. We start with 12. 12 greater than 6 condition is true. So 12 makes place for 6 and is on the left hand side, which is the correct position after comparing 12 and 6. In the next place, we will be comparing 7 and 6. This condition is also true. So 7 shift towards right to make place for 6. And now finally, my sorted array is this. So in insertion sort algorithm, the elements which are greater than the element on its right, they make place for it so that the smallest element can be moved towards the left hand side, which is actually going to be its correct place. So here is the C++ code for insertion sort algorithm. You can see I have written an insertion sort function. This function's return type is void. The function accepts two integer arguments, the array ARR and n, which is for the number of elements in ARR. These are two variables I and j, which I've used for loops. Var is the variable which will hold the number as you have seen in the example. This is the outer loop which starts with 1 because we are going to consider that the element on the left hand side right now at index 0 is already sorted. So we stored this value in variable var and we start the j loop with one value less than the value stored in variable I. So j is going to be 0 right now. And this is the while loop, which is the inner loop, which will run till these two conditions are true. So j has to be greater than equal to 0, as well as the value stored at ARR of j should be greater than the value stored in variable var. So this loop will shift the element towards right, as you have seen in the example, where this statement will move the elements to the right side one by one. So we are going to put the value in ARR of j to the position at j plus 1 index, and we are going to decrement the value of j one by one. So the loop will get over if j becomes less than 0, which is going to be minus 1 because of this decrement statement, or the value on the left hand side is already smaller than the number on its right side. So after this loop is over, we are finally going to bring the smallest element at its correct place, which will be done with the help of this statement where we store the value of var to the correct index, and this will help us to bring the smallest element at its correct position. Talking about the space complexity of insertion sort algorithm, as you can see, I have used only one variable var, which is the extra variable. So the space complexity of insertion sort algorithm is O of 1. So here is the time complexity for insertion sort algorithm. In the best case, it is O of n. The best case is when the array is already sorted. In the average and the worst case, the time complexity is O of n square. The average case will be when the array is randomly sorted. And the worst case will be when the array is reversely sorted. In the worst case, because we are making n minus 1 number of comparisons for every nth element, thus the time complexity in the worst case becomes O of n square. So finally, we should know when to use insertion sort algorithm. First, when the number of elements in our array is small and the input array is almost sorted. Thank you so much for watching this tutorial. If you like the video, please click the like button and subscribe to my channel for more videos on data structures and algorithms. Till then, keep working with smile.